This is really a pretty simple problem, so naturally I got it wrong. Okay, at the crux of it is that it's going to take, you've got an answer from f, right? Okay, and time, if you're moving at a constant speed, it's just going to be, time is going to be distance divided by velocity, right? Okay, so that's going to be 4.7 times 10 to the 11th divided by the answer you got from f. Okay. Of course, what I forgot was that it actually sits there. If you look at the previous problem, right, it actually burns the engines for quite a long time, right? The engines burn, if you could use that term for an ion drive, for 4.8 times 10 to the 7th seconds, right? So I would have gotten it right if I'd only forgotten the 48 million seconds that it was operating the engine, right? So what you need to do is the total time, right? That's what they're asking for, okay, is the burn time plus the coasting time, right? During which the velocity is presumed to be constant, right? So the burn time, you can just read from the graph, right, is 4.8 times 10 to the 7th seconds, right? And that's from the graph, right? And then the coasting time, you're just going to take the distance, right, that it travels, s divided by the velocity. So this is your s, the velocity is your answer from part f, right? Okay. And it ends up being, well, it's a long time, okay? I end up getting, is that 86 million seconds or something like that? Ends up being like 2.75 years. What's funny is on the mark scheme, I do believe, let me just look. Oh, okay. It ends up being something between 4 and 5 years, right? So they have seconds and then they have years. And I don't know whether they would accept it, but ultimately when you get your answer, if you want to get what's in the mark scheme, divide by 3600, divide by 24. Now you've got, hours, now you have days, divide by 365, right? And then you'll have years, okay? And the answer is between 4 and 5 years that it's going to take to go to Jupiter using an ion drive from Earth, including the burn time.